Today we're going to move on into section 4.5 and we're going to focus on graphing the sine and cosine functions. It's extremely important that you understand how to graph these because when we go to graph the cosecant and the secant, you'll have to graph the sine and the cosine. So you really have to have a good understanding of these. Today what we're going to do is we're going to see the two functions. We're going to treat these just like all of your other parent functions, so absolute value, square root function, the logarithmic function, the exponential function, where remember that when we talk about a function, you need to know three things: the name of the function, the equation of the function, and the graph of the function. We're going to be focusing on the graphing. After we see the two functions, original graphs, then we will transform them. So we're going to do the same thing, shift them left, right, up, down, reflect them. So first we're going to talk about the sine function. The equation is y equals the sine of x. Now one thing that is unique in this case is, remember that usually here we would use theta because it's an angle here, which is fine. You can still use that as an angle. But since we're going to be graphing this on the xy axis, that's why I chose to use x there as my domain value, because we're graphing it on the x and y axis. You're going to see some very familiar numbers here. Remember that we have to memorize this shape of this graph. On the x-axis, we're going to divide it up, and you're going to label these using some very familiar values here: 0, pi over 2, pi, 3 pi over 2, and 2 pi. They're the quadrant angles. And then the shape of this graph is going to go as high as 1 and as low as -1. And it's the reason why we choose these values is because what these values give us are x-intercepts at 0, pi, and 2 pi, a maximum of 1 at pi over 2, and a minimum of -1 at 3 pi over 2. And then we can connect those points, and they're connected using a rounded curve here. And this is that parent function, y equals the sine of x, or y equals sine theta. Our x-axis is numbered not with what you would typically number 1, 2, 3, 4, but instead with those quadrant angles. Now, a couple of things you need to know about this. Just like on the unit circle, we can rotate over and over and over again, and between 0 and 2 pi on the unit circle is one complete rotation. This is one complete cycle of the graph. We've talked about this before. That cycle of that graph is called the period. So here the period of the graph is 2 pi. What happens is after that, not after that 0 to 2 pi, the graph continues in that same shape forever and ever and ever. It just keeps going. But when we graph this, just like when we graph, for example, the absolute value graph, we graph and focus on that vertex as we shift it around or reflect or whatever. Then we just kind of sketch the rest of the graph. The same thing is true here. We're going to focus on from 0 to 2 pi, that one period, but we need to remember that this actually goes in both directions and continues forever and ever and ever. But the one period of the graph is 2 pi. A couple of other things you need to know is this x-axis in this case, try and make this red show up a little bit by putting it a little bit higher. Basically, where this graph is revolving around or waving around, see how it goes equal above and equal below? This is called the midline. When we go to shift the graph up and down, it's actually the midline that's going to shift up and down. So that's our midline. And then finally, the last thing that's pretty important that we need to talk about is the distance from the maximum value to the midline is called the amplitude. It also can be the distance from the midline to the minimum value as well. So the amplitude here is equal to 1. And those important features are going to help us when we go to graph the transformations of this. So the name is the sine function, the equation is y equals sine x, and then this is one period of the graph. Although we will have to end up graphing 2 periods when we go to graph this. All right, the second one is the cosine graph. So the name of our function is the cosine function. The equation is y equals cosine x, or y equals cosine theta is how you're more comfortable seeing it. And I'm going to try here when I draw this to make my x and y axis line up here. And then when I go to label my x-axis, I'm also going to try and line up the quadrant angles here. Pi over 2, pi. Just because you're going to see that these graphs are similar to each other, in that we're going to use the quadrant angles again. The quadrant angles provide for us our x-intercepts, our maximum and minimum values. Although for the cosine graph, these are a little bit different. Instead of starting out with an x-intercept like we did up here, we're going to start out with a maximum value. And then we'll have an x-intercept, and then a minimum value, and another x-intercept, and then a maximum value. And when we go to connect these, even though it looks like a V-shaped graph, you have to connect it so that it is curved. And as a matter of fact, so you can see here how it's different, still going from 0 to 2 pi. But if I was to continue this graph out, the wave is actually exactly the same. You can see here, if I was to focus on here to here instead, it's the same as the sine graph above. There's some other things that are the same. 0 to 2 pi completes one cycle of the graph, or one period. So our period is 2 pi. Our midline is still the x-axis. So that's still what we're waving above and below. Our maximums and minimums are equidistant above that midline, which is very important. And then our amplitude is still the maximum to the midline, or the minimum to the midline. So again, our amplitude here, the distance between the max and midline, is equal to 1. So there is our second function. So these are our 2 new functions that we're going to add. And just like from before, when you would learn a new function, like the exponential function or the log function, you're going to have to memorize the shape of this graph, because we're going to take the shape of this graph and we're going to be transforming it around the x and y axis. In order to do that, we are going to do something a little bit different than we did before. Before, we used to just be able to look at, multiplying by -1 and where that happened, or add a number and where did that happen. And that still is kind of the case, but we're a little more specific with this. And we use something called the general form.